My name is Jeff Grassberger, and today I'll be presenting as part of the WEC-Sim technical training course for users and developers. And I want to note that this presentation is based on WEC-Sim version 5.0. Today I'll be talking about WEC-Sim visualization, which is one of our advanced features within WEC-Sim that allows you to visualize the waves, the body, and the overall simulation. First option in WEC-Sim is visualization with SimScape. This is WEC-Sim's default visualization when simu.explorer is set equal to on within the WEC-Sim input file. This turns on the Mechanics Explorer by default. It cannot be used with accelerator or rapid accelerator modes, and the animation shows the rigid body motion and can be saved as a video file. This animation does not show the incident radiated or diffracted wave surface elevation, so you don't really have that context between the body motion and the wave elevation and wave motion. But it does at least show you the basic body motion and allow you to see a little bit of that reaction and response that's happening. To provide a little more context, we've created 3 other simulation visualization options within WEC-Sim. The first is the save visualization option. This is done as a post-processing action within the user-defined functions, and it creates a MATLAB 3D surface plot of the WEC-Sim bodies as well as the wave surface elevation. The next option is the Mechanics Explorer wave markers. These are specified within the WEC-Sim input file and applied in Simulink, and they show up in the SimScape Mechanics Explorer, so it's kind of an addition to that default SimScape Explorer option, and shows or adds those markers that are shown there. And lastly, the ParaView option is a post-processing visualization option, where the results from the WEC-Sim simulation are saved as a ParaView file, and then you can load that into ParaView, which is a separate software outside of WEC-Sim, in order to apply different visualization features for the body's surface elevation, forces, etc. Next, to give a little insight into the save visualization feature. First, it is a response class function called saveVis, and it creates a 3-dimensional plot of the body and wave motion. It's called by the user-defined functions.m script. We have an example for this in the ARM3 example within that user-defined function script. And it shows the incident waves, but not the radiated or diffracted wave surface elevation. So just showing those incident waves that are interacting with the body, but it doesn't show the waves that are caused by the body itself. But it does show the reaction of the body to those incident waves. Some options for the save visualization feature is the times per frame, so the number of simulation time steps per video frame, so you can kind of make it so that it goes faster by doing a greater number of time steps per frame video. The axis limits are the x, y, and z bounds of the figure axes to kind of zoom in and out. The start and end time of the video specifies how long the video goes, and the save setting allows you to save as an AVI or a GIF file. And the example script to complete this plot is shown at the bottom. Alright, so to show an example of the saveVis feature, we can go into the ARM3 example, and in the user-defined function script, uncomment this output.saveVis function call, and then I'm also going to set the simu.explorer equal to off so that it doesn't do that, and run WEC-Sim here, and once WEC-Sim successfully runs, the figure will show up and start plotting the save viz over the time span specified, as you can see here. And then once it's finished, we can go to the ARM3 files, and we can see, in this case, I saved it as an AVI file. So we can see this saved video file here. Which can be used to play back the results. Next option is the Mechanics Explorer wave markers. These appear in the SimScape Mechanics Explorer, so again, kind of in addition to the default WEC-Sim visualization option. The global reference frame block adds these wave markers to the simulation based on the specification in the WEC-Sim input file. These show the incident, but not the radiated or diffracted wave surface elevation, similarly to the Save Vis option. Some options for these are the location of the markers. This can just be one point or an array of points to specify multiple different wave markers. The marker style, so a sphere, cube, frame, etc. And the size of the marker in pixels. So now for the wave markers visualization, we can comment out that Save Viz feature, turn the Sim.Explorer back on, and then lastly, I've already written it up to save time, but we can specify the location of the different markers, the style, as well as the size. I'm going to up this a little bit so they're a little larger. And then we will run WEC-Sim here. And then you'll see in the SimScape Mechanics Explorer the results here. And you can see those wave markers visualizing the wave surface elevation at each of those points. The last visualization option is using ParaView. WEC-Sim is compatible with ParaView version 5.11.1, which is an open source data analysis and visualization application. The benefit of this is using ParaView to create videos, visualize the wave field, visualize nonlinear forces, as well as other features. And the con is that it takes a lot more time to run, but it is worth it if you'd like to get those visualization features. Some examples using ParaView for WEC-Sim are available on our applications repository on GitHub. We have an example for the OSWEC with nonlinear forces and the ARM3 with Mordyne. Because ParaView is a separate software from WEC-Sim, it needs to be downloaded and installed separately. So you can go to paraview.org to download the version 5.11.1. For running ParaView, you'll need to have Python downloaded and installed to use the ParaView macros. And for WEC-Sim, we have some specific macros that are provided within the WEC-Sim source. So if you open up ParaView, click on the macros and add new macro, then navigate to the WEC-Sim source folder, and under functions/ParaView directory, we have the WEC-Sim.py and the pressureglyphs.py macro files. And both of these being added will allow you to apply the WEC-Sim visualization features within ParaView when looking at WEC-Sim simulation results. So quickly, I just wanted to demonstrate the macros loading within ParaView. So here I have ParaView 5.11.1 open. If I go to macros, then edit, and then import new macro. And for me, it's within Documents, GitHub, WEC-Sim, Source, Functions, ParaView. Then I can add these both one at a time. Import new, WEC-Sim, and then they'll show up over here and be available to use. So quickly, I wanted to demonstrate how the WEC-Sim macros can be added to ParaView. So first, I have ParaView version 5.11.1 open, and then I navigate to macros, then import new macro. And so I will go within the GitHub folder, within WEC-Sim, source, functions, ParaView, and then we have both the py files here. So I will add those each one at a time. And you can see they showed up over here, are available to use when needed for the WEC-Sim visualization. In order to run the WEC-Sim ParaView visualization within the WEC-Sim input file, the simu.paraview.option needs to be set equal to 1 to turn ParaView on. This creates a VTK directory within the WEC-Sim case directory, within which it saves the ParaView data files. Then, within ParaView, the .pvd file can be opened to view the data visualization, and then you click Apply. Then the model can be selected in the pipeline, and the WEC-Sim macro can be ran to import the default WEC-Sim colors and orientation. The WEC-Sim macro extracts each body, then sets the color and opacity. Then it extracts the waves, sets the color of them as well, creates a ground plane, and sets the camera to the parallel view. There are multiple different options and features within ParaView, including the nonlinear hydrodynamics, video export, save state feature, etc. So first, for the nonlinear hydrodynamics, the body can be selected in the pipeline, and the pressure glyphs macro ran to add glyphs for the hydrostatic pressure, the Froude-Krylov forces, etc. These can be seen on the right-hand side there. Specifically, the Froude-Krylov pressure force is plotted there. We can also add multiple views, slices, and data filters to format the visualization as desired. The formatting can be saved using the Save State feature to recreate the visualization for many different runs. This can be done by going to File, Save State, and saving as a PBSM file. Lastly, a video file can be created by going to File, Save Animation, to save as an AVI file. As mentioned previously, there are a few different examples for ParaView within our WEC-Sim applications repository on GitHub. These examples include the OSWEC with nonlinear hydrodynamics and the RM3 coupled with Mordyne, both of which you can see on the bottom of this slide. First, for the RM3 coupled with Mordyne example, within the WEC-Sim input file, there are a few options specific to ParaView. The DT out is used to specify the output time step for ParaView. The ParaView.option is set equal to 1 to ensure the data is saved for ParaView. The wave field viz options are used to define the number of points in the X and Y directions. And the mooring lines are set up here, of course, to apply mooring, but also will be visualized within ParaView. Similarly, for the OSWEC example with nonlinear hydrodynamics, the simu.pressure is set equal to 1 to save the force data for the ParaView visualization. Again, the simu.paraview.option is equal to 1 to save that data for ParaView. The wave field viz options can again be adjusted for the number of points in the X and Y directions, and the body visualization options can be set to determine the color and the opacity of the body. Alright, so I wanted to demonstrate how WEC-Sim works with ParaView. So within the WEC-Sim applications folder, we have our ParaView visualization folder, including the OSWEC with nonlinear visualization and the RM3 with Mordyne. So in the RM3 well, in both WEC-Sim input files, the simu.paraview.option is set equal to 1, which allows those ParaView output files to be saved in this VTK file directory. So you can see the arm3 moredyne.pvd file here, which we will use in ParaView. So now I'll go to File, Open, and then navigate to that ParaView application folder, and select the PVD file. Then we hit Apply, and you can see the visualization shows up here, but it's not quite in the format we want. So we click the WEC-Sim macro that we have loaded, and that will apply different colors just to format that visualization a little bit better. Now you can see the wave elevation, arm3 device, the mooring lines, and the ground. We can also go and load the .pvsm state. So if we go to back to that same folder, we see .pvsm, click OK, and then with this we search files under specified directory, and make sure that's on the arm3 moredyne VTK directory, then hit OK. And this will show the 3 different viewpoints, as well as mooring line forces, the wave elevation colored, so that we can visualize this a little more intuitively. And this can be, these PVSM files can be saved for multiple different viewpoints as desired. So next I wanted to also show the OSWEC example real quick. So if we go back to the OSWEC and then that PVD file, and then click Apply, and then again hit WEC-Sim, and select OSWEC again and hit pressure glyphs. Then we can zoom in on the OSWEC, and let's visualize, for example, the hydrostatic pressure. And we can see that that one doesn't change much over time, but we can also look at the Froude-Krylov pressure. And as the wave forces are ramping up some, we'll start to see the Froude-Krylov pressure appear on the surface of the flap. Yeah, you can see it appearing there. This will conclude our WEC-Sim visualization webinar. I hope this provided a good reference for our different WEC-Sim visualization options. Thank you for watching.